Alright guys, welcome to part 2 on my Solving Systems of Equations series. This next part, we're going to work on graphing systems. And actually, instead of writing on this paper, let me pull out some pretty graph paper. Alright, so we'll be working on graphing systems. Alright, so first things first, we need a system to graph. So I'm going to graph in 2 different colored pens, and hopefully it shows up on here, and I think it will. But the reason I like to graph in multiple colors is so that you can see like which equation goes with which line and whatnot. So we're going to graph this system. We'll have 2 equations. We'll have y equals 3x minus 4. And then we'll also have y equals negative 1/2 x plus 3. Okay, so I've drawn our coordinate grid. We'll graph this one in pink first. So we start with our y-intercept, which is at negative 4. So we'll go down to negative 4 on the y-axis. And then my slope is 3, which means I go up 3 units and right 1 unit. So I'm going to go follow that same pattern, up 3 and right 1, up 3 and right 1, until I run out of room. I'm going to do the same, I'm going to do the opposite. I'm going to go down 3 and left 1 to finish it out. Let's see, I think my handy dandy straight edge that's always on me at all times, like yours is, I think that's going to be too short, but I should still be able to get through and scoot down. So, there we go. Alright, so there's my pink line. There's the first, my first equation in the system. Alright, we'll graph our green one. So our green one starts at 3. And my slope is negative 1/2, which means from this point, I'm going to go down 1 and to the right 2. Down 1 and to the right 2. And you can already see where it's going to cross. But because I'm a nerd and I like for the whole, we don't want to graph just part of the line, we want to graph the whole line. Again, because I'm a nerd. And I feel like that's more correct. Okay, so I have my whole line plotted out. We will connect my dots. And so I'm going to find their point of intersection, which we can already tell is right here. And that would be at the point 2, 2. So my solution is 2, 2. Okay, so you should not have to ask me, is this right? Because what you can do is take this point and plug it into both equations and see if you get a true statement. So we can take 2 and plug it into this pink equation. I'll write everything else in pink other than what I'm plugging in. So I have 2 equals 3 times 2 minus 4. 3 times 2 is 6. 6 minus 4 is indeed 2. So it's a true statement. So it is a solution to the pink equation. So we did that right. Okay? So the second one, we're going to plug 2 into the green equation. So we have 2 equals negative 1/2 of x. X is 2. Plus 3. Half of 2 is 1. Make it negative, it's negative 1. So we've got 2 equals negative 1 plus 3. Negative 1 plus 3 is the same as 3 minus 1, which gives me 2 equals 2, which is a true statement. Boom. That is the solution that they share. Yay. Okay. So there's one. I'm going to do one more. Actually, if you would like to pause the video and try it on your own, That would probably be a good idea. Ooh, we're gonna make this a little more complicated too. Actually, you know what, since I'm gonna make it more complicated, I'll do it with you. Or I don't know. Maybe you could try it on your own. You can always pause the video and try any of these problems on your own if you want to be honest about it. So I'm going to skip a little bit of room. We've got 7x minus y equals negative 3. Okay, so my system, I have 2x minus 2y equals 6. And I have 7x minus y equals negative 3. Okay, so if I want to graph this, I need them in slope-intercept form. Or I need Desmos, one or the other. And I don't have Desmos right now, so we're going to do slope-intercept form. So to get this into slope-intercept form, we need y by itself. So if I'm going to do the math over down here. So I have 2x minus 2y, highlight y so that we know that's what we're trying to get by itself, equals 6. So I need the y by itself. So I need to start moving things over to the other side. So I'm going to move the 2x first. So we'll subtract 2x from each side. And I've got minus 2y equals, do not tell me 4x. If you tell me 4x, I'm going to hit you. I'm just kidding. We're just going to have 6 minus 2x. You can't combine two terms that don't have the same variable. Or you can't combine a term with a variable with a term that doesn't have a variable. It just doesn't work that way. Okay, so then I've still got to get y by itself. I need to get rid of this 2. So I'm going to divide both sides by 2, or by negative 2, excuse me. Divide everything by negative 2. Now if I divide by negative 2, or if I divide both sides, I got to divide everything. That's what I'm trying to get at. So the negative 2's cancel. And I have y equals 6 divided by negative 2 is negative 3. Negative 2 divided by negative 2 cancels, and I have positive x. So y equals x minus 3. I just swapped those because it was easier. All right, so I'm going to rewrite that up here. I have y equals x minus 3. And I'm going to graph it. So we'll start at negative 3 on the y-axis. And my slope, I don't have one. Which means my slope is an understood 1 in front of the x, so it's just going to go up 1 and over 1. Up 1, right 1, up 1, right 1. And we'll continue this as well. And there we go. So I have my first line. And we'll graph my second line. Now my second line, I also have to get that into slope-intercept form. So there's a couple of different ways you could do this. Again, you want y by itself. I don't want to deal with negative y. So what I might do is I might actually add the y to both sides first, which would give me 7x equals y minus 3. And then just add the 3 to both sides, and you've got y equals 7x plus 3. All right, so we'll start at positive 3. And my slope is 7, which means I go up 7 units and right 1 unit. So 1, 2, 3, 4, 5, 6, 7, 1. 1, 2, 3, 4, 5, 6, 7, 1. 1, 2, 3, 4, 5, 6. I don't really have a 7, so. Okay, that'll work. And we found the intersection point. That would be right here, where those two lines cross. And that means their solution is negative 1, negative 1, 2, 3, 4. Negative 1, negative 4. Okay, and again, you can check it by plugging it into both systems, or both equations in the system, and that should be the right answer. If I did something wrong, let me know, but That's right. That's what I got earlier, so I think I'm right. Okay, so again, cutting this out after 10 minutes because I know y'all can't pay attention for quite much longer than that. And I say that out of love. Y'all know I do. So I'll end it here. And actually, this is a good place to end it because I've done 2 graphing problems. So I'll end it here. The next video, which will be part 3 in our series on solving systems of inequalities, that video will be on solving using substitution. So thank you for your attention, and I will talk to you soon.